people. Computer vision, wow. Um, we'll hang in a little bit more for some other people to come in maybe. How's everyone doing today? Doing good. I've had so many caterpillars fall on me within the last week. Have you experienced that?
Not this year, but last year, I had one just fall on me. Like,
Yeah. I went to a food truck, got food. I went, walked kind of where University Avenue is, and I sat down at a picnic table. I was just eating. I was just eating like jollof rice, and then I was like something hairy on my neck, and I was like, "Oh my goodness, it's a caterpillar." I was like, "Hey, what's up?" So, yeah, that's crazy. I'm from South Florida, I'm from Miami. I'm like not really had to deal with that sort of thing. Where's everyone from? Yes, photograph. We're all Floridian. Hey, love it. Got a nice little technique here. I love it. More questions? Um, so let's go ahead and get started. I think we're all ready. You're rolling. Uh, Computer vision and data annotation workshop. Okay. By the AI Club. You guys haven't heard of the AI Club? It's a brand new club at UF. We're doing everything AI, but it's not limited to the computer science. It's also physics, right? We want to be able to everything. AI Club is for everyone. We really try to put so that everyone really made their response. Using it for things that from the law. Does anyone know what altruism is? What's altruism? Workshop, but yes, doing stuff for the maybe a bit of money. Answer question. Answer question. A little bit about myself on the topic of altruism. I might have to actually like flip back and forth here. Let's see. Oh, that was a little bit too much. Okay, about me. My name is Jacques Fleischer. Please call me Jacques. I feel like I'm I am research. So now it makes sense. My George Jones. That's MBC. I graduated from the Honors College. And for the summer but my time I participated in several universities at RU. Research. Happy. And I cannot recommend. My first research experience was at FAMU. I did an RE on predicting cryptocurrency prices. Then I went to UVA, University of Virginia, predicted earthquake forecasting. Went to UF. Now I work in the Malt Lab. Malt Shake. I do that with Dr. Sanjay Ranga and Dr. Rangaraju, where we look at traffic. Most recently, I went to NREL, National Renewable Energy Laboratory, at the Department of Energy, where I predicted carbon emissions, transportation, love transportation. And I'm part of the Barry Goldwater Scholarship, amazing foundation. Can't recommend that enough either. Ask me more about it. This is my website. Enough yapping about myself. What is computer vision? What is that? Can anyone tell me what computer vision is? There's not really a right or wrong answer.
I guess for me, it's like how can by processing your code for you, try to find the features, and you gotta go through everything, like whatever. So, Something like that.
I like the distinction also between dog and cat, and also the word features. Feature. Feature. What is a feature? Well, when I was born, you know what a water bottle looks like? What does a water bottle look like? If I look at this, what features does it have? It's clear. It's translucent. What else? What else? You get a candy. It holds water. Okay. What does that mean? Visual.
Maybe you look good.
Okay. We're getting somewhere. There's a line. What else? Okay. We're getting a little bit abstract, but can we think of, I went to art school, high school. Can we think of the shape? The shape? What's the shape? Cylindrical? Okay. Okay. There's a cap. It gets narrow at the top. This is really all of these features let us know that that is a water bottle. We've seen so many water bottles. Know what a water bottle looks like. It's ridiculous to say that. Especially when it pertains to computer vision. When you're trying to teach a computer what stuff looks like, you have to think about all of the specific objects. Okay. So TV is for teaching computers what stuff looks like and inferring what's what objects are in that? There's different classes. A class. What's a class in detecting objects? You know. Okay. Okay, I like that. Okay, so when you have several classes, which is short for classification, not like that, you are trying to differentiate objects in the image from each other. So I can say this is a water bottle, this is a bicycle, this is a car, this is a teddy bear. All these different things are classes. These are classes here. Okay. What do people use computer vision for? What do you think is the most common? Face detection. Yes, I can hear. Anything else? And you get it right at home too. That's part of all that. This is kind of funny. One of the most common video games. People use it to track power. To win right point at the end and just eliminate extremely quickly. Is that altruism? No. You have to think about, especially when TV applications are open source. Well, we use the MATLAB for tracking and detecting parties. Okay. Let me hide this and oh, what did I just do? I don't want my music to go. Oh, there we go. We're back. We're so back. Okay, what are all of these funny looking things on the screen? Does anyone know what these things are? Has anyone heard of them? Okay, it looks like alchemy. It looks really funny. It looks like well, kind magic, but technically. Hey, welcome. Come in, come in. So these are different software packages. We have YOLO, we have CVAP, we have Darknet. Okay, all of these things. I think this one's interesting, right? Because I think we can have a good guess what the first two characters stand for in CVAP. What would that be? Computer vision. What about the last two? Yes. And you get a candy. Annotation too. Computer vision. It's funny because what is annotating? Annotating is what researchers have to do. You have to annotate. I have a picture of an intersection, and there's cars in the intersection. I have to annotate the cars. Hey, this is a car. This is a pedestrian, a truck, a bus, living bag on the picture. That's marking. You have to do this. This is a crucial part of training a CV model. What's okay? Conventionally, what that is, but it stands for something else. We know it as you only live once, but it is known as you only look once. You only look once. Because that type of model, the YOLO model, only needs to look at a picture once, and then it knows what's inside the picture. If it detects what's inside the picture. It is a CV model. It's a type of model. That's darknet. What's darknet? Well, darknet is an open source program software tool that's written in C++ that allows you to create models. It allows you to configurations of models, one of them being YOLO. Create a model, give us a model. And today in this workshop, we are going to be using CVAT to annotate some pictures, and you're going to help. All of you are going to help. If you have your laptops, take them out, and they're going to be a bit of part of this workshop. Okay, interesting. So let's see what's next. But before we annotate, we must know a golden rule. A model is only as good as its input data. A model is only as good as its input data. A model is only as good as its. The model is only as good as its. It's weak. It's weak. Weak. A model is only as good as its. Okay. Input data. Absolutely. And this is something we must know when we're training a model. The data has to be immaculate. You cannot have any mistakes, because if you introduce mistakes into your annotations, the model is going to think that it's true, and then it's going to pick up on it and repeat that mistake when it is using in real-world applications. You have to be precise. You have to be perfect. So it's a lot of pressure. Well, let's try it out. What are their names? Raise your hand. And yes, Albert and Albert. Those are our favorite leaders. Well, here's a cinch. Someone has to push all of these on people, and this broadcasting corporation has approached us. They've given us. They don't watch the members on the team. A little bit. They were secret shot, zooming through the ice. And on screen, his Nick as the player is moving through this. This is an example of a scene. how does it know where to shop? Okay. Well, let's say ESPN has approached us and they want us to make a gator detector model for the Florida Gators. It's a big task, but I think we're up to it. All of you are fantastic people, and I think we can make this model. Gator detector model. So can we find where Albert and Alberta Gator are in various pictures? The bounding box is the bounding box around Albert and Alberta. And we want to make a model that detects where they are in certain pictures. So in the broadcast, we can maybe, for example, have a name tag up on top. That's Albert, and that's Alberta. That'd be pretty cool, wouldn't it? Well, I need your help. We need to make this happen. We need to make this happen right now. So everyone on your laptop, go to this link, and my face is kind of blocking it a little bit. sunshine.cisc.ufl.edu:ADU. And you must be on EDU realm. You must be on the Wi-Fi network EDU realm. If not, no fear, you can come up and we'll do some line annotation on this laptop. Not working. Does anyone else smash it? You can log in with it. Also, let me actually. It's working? Oh, cool. Okay. All's well that ends well. Is everyone on the page? Okay, so we need number 1, annotations, number 2, negative samples, number 3, a good GPU. But I think we have all those bases covered. Okay, so everyone raise their hand. I'm gonna start dishing out tasks. Everyone raise them. 1, 2, 3, 4, 5, 6, 7. Okay, you have all assigned a number. You all have a number. So go to that task, and I'm gonna do that right over here. So here I am on the page. I log in, AI Club, annotation time. Might have, yeah, we're so back, all right. So I go to the task. For example, if I have task number 8, I look at number 8. I click open. Job number 8. So open up that job, and we have the Gators are cheering. They're so happy. Oh my goodness. We have them here in this picture. This is CVAT. You're using the computer vision annotation tool right now. Let's learn how to use CVAT. All right. Well, we have some tools on the left side. We have a toolbar with all these tools. What we're most interested in is the rectangle. I click on the rectangle. I click the class. It's also called label. Albert. And I click on shape. And I'll do that one more time. Click on the rectangle. Click on the label. I'll do Albert first. And then shape. And then my mouse turns into a crosshair. I start marking. I click and drag, all the way, making sure all the features of Albert are in the box. And I click again. Does that look good? What do you think? Looks pretty good. Does anyone want to come up and give it a try? Yeah, awesome. Yes. Let me just delete this. You can stay right here.
Yeah.
All right. We're gonna have 5 demonstrations. So let's mark out in Alberta. What should we do? All right, rectangle. What next? All right, we have one shape for Alberta. What about Alberta? Absolutely. And fantastic. And now make sure we get the entire extent of Alberta that we want the top of it all the way to the bottom. Make sure all the features are in front of you. That was absolutely fantastic job. All right. And now what should we do? We're not quite done. We want to make sure we block annotations by clicking save all the way to the top left. Make sure that you save. Also, you're gonna get around the ball. Yes, absolutely. Absolutely. Cool. Very good. All right. So, if you are done with your current task, feel free to go to the tasks tab and look at other tasks and do other tasks. We don't have enough people for all time, but we can certainly go and do it ourselves. Would you like to do another?
Sure.
Okay, go to tasks. And let's see, try 20. Open that up. And by the way, if anyone would like to join us, we are on the website sunshine.cisc.ufl.edu at port 80. So if you would like to join, just go ahead and go to that website with the username AI Client. All right, so who do we have in this picture? Albert. We have Albert. Let's go ahead and look at Albert. The entire set to the top is out, all the way to the bottom of the curve. Make sure the entire bounding box has everything. Absolutely. Awesome. Have we had the name of it now? We don't have this is it. It really is. And people look for me who know how to use that. Not everybody knows how to use that. Thank you so much. Well done. All right. So we're going to go ahead and make sure that we'll start before we go ahead and train them. So, that's everything. They're all done? Okay. Yeah. Because we do have some people who are assigned for it. All right. Now I'm going to demonstrate. Oh, by the way, you're going to come. Yes. Thank you so much. All right. Let's see what we have here. Oh, they're not all done. Okay, everyone start roaming. So go to the tasks. Go to the tasks. That might be for that particular task, like there's only one job. For example, if I go to 14, and I click on 14. Let's see how this is going. Okay, so this one. How do I do this? Click on rectangle, shape, click and drag. Boom, bada bing, bada boom, easy as pie. I click on save. That's it. That's all I have to do. Click on tasks. There we go. Let's go. If you see one that's not done, go ahead and mark it up. Job 20 looks good. Job 19 looks good. Oh yeah. And by the way, something to know is that how does the model know where everything is? It takes into account every aspect of the photo. A lot of different aspects, not only location, but also where the object is relative to other objects. If we only had pictures of Albert and Alberta together, and then I showed the model, hey, what's in here? It might think that Albert is here when there's actually nothing. That's something you have to consider. You need to give the model all sorts of variables. Alberta alone, Albert alone, both of them, Albert on the left, Albert on the right, nothing. Sometimes you need negative samples. What's a negative sample? Raise your hand. None of them appear. None of them are in the picture. That's a negative sample. And a positive sample is there is something in the picture. So looks good. How are we doing on tasks? Go to the number 18. Yeah, you just hit save. Absolutely. This looks awesome. Task 17. And you see some of the negative samples. I think I took a picture of Ben Hill Stadium where there was like nothing. That's something we might expect here. Let me go mark this one. Alberta and Albert, just like that. And Alberta and save. Looking good. Number 16. Albert. All right. So this looks pretty good. So what we have to do now is we have to retrieve all of the pictures that we have on CVAT. We do that using something called an API. What does API stand for? Application Programming Interface. Absolutely. So we've developed an algorithm. Actually, Sorghum has developed an algorithm in the crowd here. I hate to put the spotlight on you, but she is part of our Malt Lab. And what we have developed is an algorithm that pulls the pictures from CVAT, and we can take them and put them somewhere else in preparation for model training. Okay, let's see here. So we do this using a GPU called the A6000. The A6000. Anyone want to guess on a scale of 1 to 10 how powerful that GPU is?
9.
Nope, lower.
7.
Higher.
8.
I'm just gonna ping pong you a little bit higher in the middle.
8.5.
It's gonna be 8.6, which is interesting, right? Because if I look at this number, I'm like, well, relatively speaking, that's not the most powerful GPU. I want the 10, but the 10 GPU is the cost of like 3 cars. Like the H200 is like $60,000, and it's only used in data center workstations. But let's go ahead and let me go back a little bit. Oh, not that far back. Does it come back? We're gonna come over to our Linux machine. We're running Ubuntu on one of the MaltLab servers, self-managed server. Sunshine is one of the servers. Signal is another server. So you guys were all using Sunshine. That computer is tucked away on the 3rd floor of the old CISD building. On the 3rd floor, locked with a mobile key. You cannot get in. The cumulative amount of hardware in that room is like $200,000. So we are connecting to these machines that are behind the US firewall. I'm remotely connected to Signal right now. So what we're gonna do is we are going to pull all of the annotations here. So let's see here. Let's see the algorithm we have developed. We have a makefile that runs a Docker container. Anyone know what Docker is? Anyone know what Docker is? Docker is containerization software. It allows us to run a program in a container. It's kind of like a virtual machine. It's virtualization. So in this Docker container, we are asking CVAT for those lovely, lovely annotations that you all have prepared. We're copying them from Sunshine. And it's going task by task, downloading all of those pictures and all of those annotations, waiting for the server to prepare the file, downloading all of those lovely tasks. And the kicker is that all of the software that we're using is open source. It's all open source. CVAT is open source. Docker is open source. Darknet is open source. We're going to use Darknet in a little bit. And so if you are not satisfied with the way those software works, you can suggest changes. And that's what we've done in the Malt Lab. We've worked with these developers, especially in CVAT or another annotation tool, Darkmark, and we say, this isn't really optimal. Can we change this? Can we add this new tool? Can we make annotating easier? And that's the wonder of open source software. That's why I love open source. You'll always hear me saying two things: open source, altruism. Open source, altruism. Help others. Disseminate your work. Share it with people. That's how you make amazing things. It's amazing. So let's see how we are here. Task 15, so we're on 15 out of 20. Slowly churning. Good question. Don't know. It should be faster, right? I know. And those are so small too. 51 kilobytes. Maybe the API needs some optimization. Or maybe the networking in that self-managed server room is not good. The wonders of research. You have to figure out why things don't work. Okay, let's see here. So we're gonna say copy annotations.py. And what this looks like, let's say sudo cat annotations. The annotation. We are copying all the pictures to Darkmark. What's Darkmark? Does anyone know what Darkmark is? Darkmark is a tool, a really sophisticated annotation tool that lets us mark up faster than CVAT. I'm kind of deceiving you guys because I was like, here's CVAT, have fun with CVAT, but this is so much better. Darkmark is so much better than CVAT. Something we've learned very well in lab. Let's see what annotations we have here. The problem is that you cannot work together on Darkmark. That's why we use CVAT. All right, looking good. Wow, fantastic. Okay, so we have a double annotation here. So I'm gonna click on this and hit delete, and we're good to go. Absolutely. So it's gonna think that there are two Alberts. The model will think that there are two Alberts when there's actually just one. And sometimes there might be two Alberts. Maybe the Florida Gators are like, wow, Albert is so cool. We're gonna have a second one on the field. But we don't want the model to be confused in that scenario, you see. A little bit more here. Let's delete them. Let's delete them. Looks good. I like that. Perfect. Looks good. We have another one. Let's hit delete. Looks good. Looks good. Let's see how many are on here. Image, 2 marks. Looks good. Wow, this is perfect. I love it. And we have the negative sample, like I was talking about earlier. Negative samples are crucial to training your model. You need the model to say, hey, there's nothing in this picture. It's more crucial than you think. Actually, 50% of your data set should be negative samples, but we only have 2. So let's see how that works out for us. Okay. I'm going to make some files. YOLO, see we're using YOLO v4 Tiny. This is the configuration that we're using.
This is the dimensions of the model that we're generating, 352 by 256. It needs to be relatively small or else it won't be fast. The number of batches, 1600 batches. And let's go ahead and click on OK. Cool. So the only thing left to do is to start the training. Let's see here. Let me go to my terminal. Let's see. And we have a bash script that is generated, annotations train.sh. This is a bash script. It's gonna show us what happens during training. Let's see. And it uses the darknet detector and train, uses the train flag. All right. Let's go ahead and start. Yeah.
Is the bottom or dot? Here's where the bottom goes. Just electric
Dot weights will be. Does that answer your question? The file is a dot weights file. We haven't made a model yet.
Oh, okay.
Yeah, we're gonna make it. We're gonna make it right now. Let's. I'm gonna go new window, CD, data, AI Club annotations. Start this up. We're gonna start up this special thing over here. The suspenseful music button. What's that about? I have no idea. Well, anyway, let's go ahead and start annotations train.sh. Let's say I have God chart.png. Okay. We have a lot of stuff going on here. What is this? Kind of makes me dizzy. Progression of some training going on here. This is the batch number, some loss, average loss, training rate, how much time is left. It's a lot of stuff going on here. Oh, it's gotta be louder than that. It's gotta be louder than that. Okay, loud as it can be, no problem. What's that? Okay, what's the blue thing here? Loss? It is loss. What's loss?
Loss indicates how bad your predictions are.
Okay, yes, I like that definition here. So we want the loss to be as close to zero as humanly possible. This is a measure of precision. As the training progresses, we want the detections, bounding boxes, to be close to Albert and Alberta. We need the loss to be hitting the floor. It needs to be as close to zero as possible. And the way to measure if the model works or not is to show the model a picture that it has not seen in training. That is how you validate the model and make sure that it actually works. Okay, so we're progressing, going right along here. 90 seconds left, almost there. It's actually training insanely quickly, and the loss is going down and going down and going down, converging here. All of the features of Albert and Alberta are being generalized by the model. Alberta has a skirt, pleats in the skirt, lipstick. Albert wears a hat. The clothes, the color of the clothes, all of these features are being learned by the model. Okay. What is that? What is the red? What is that? Does anyone know what that is? Okay. It stands for mean average precision. Mean average precision. It is skyrocketing. Skyrocketing. Close to 100%. Close to 100%. As humanly possible, have the best country are 100%. And the loss, the toes, and we know that we have done a great job. It is just about done. 15 seconds to go. It is almost done. I am so hyped. Here we go, 100%. Diverging, 6, 5, 4, 3, 2, 1. We've done it! Oh my goodness! That was amazing. We just trained a YOLO V4 tiny model in 3 minutes. Okay, wow, JP. So much hype for what? What is the use case of this model? What is the entire point? Well, we have to put it to the test. Let's put it to the test. Let's see. Let's take a picture that the model has never seen before, feed it to the weights that was generated, and see if it's accurate. Okay. So I have a picture here, and feel free to call me out if you did see this picture on CVAT. This one. Let's see if it knows what's inside this picture. Okay, so it didn't entirely work. So what do we have here? We see that Albert was detected with 0.98% accuracy. That's really good. What about over here? What happened over here? Can anyone tell me?
Thinks it's Albert.
It thinks it's Albert. Absolutely. It says with 0.45% accuracy, that is Albert.
Alberto.
Exactly. So let's go ahead and see what happened here. The terminal says 98% accuracy for Albert, 45% in the other one, and Alberta was 35%. So how can we remedy this? How can we make it better? More data. Yes. More features. Okay. Yes. Yes, absolutely. Maybe there was not enough pictures of Alberta. That is true. Another thing is that maybe there were not enough batches, or maybe there were too many. Maybe it was overfitting. Something to think about. Did we succeed? Did we? No. We didn't. And that's the wonders of research. Perfect. Different model sets of data. And what can we do better? It takes a lot of work. It's easier said than done. Alright. How can we improve the model? But what can the model do? I implore you to use it in any video. All of these different applications are possible with CVAT. And part of what we do at the Malt Lab is that we test model train on different computer environments. And this entire process, we do benchmarking of the model train. Big large line that you guys think, let me ask you a question. For model training time, when you have these amazing, like anyone, are they faster? Or are they slower? Or are they about the same? Training time. Are they faster, slower? You gotta give out all this time. Come on. Maybe they're faster. Okay. You think they keep finding? That's right. You think they're faster? Yeah. You think they're faster? They're not. They're not. They're not faster. In blue, we have hypergators. high performance computing cluster. Really are after that. In order to get hypergator, Afton is the HPC hypergators at US. The A100, 1,000 seconds for a YOLO before typing, but over here, well, there's different statistics to think about. We are so powerful on the high school because they have so much. What's you louder? Yeah. Okay. The memory component of the GPU for before time. Or that is just not possible. That's essentially. So, well, that concludes this workshop. I hope you had a great time, everyone. I thought it was lots of fun. And I hope that this sparks a drive in you to learn more about I love research. I'll probably do it for the rest of my life. And hope you guys enjoy it. I'm here for any questions, any comments. If not, I'll see you around. See you next time. Oh, that's a good question. I got interested in so I think it started just with AI in general. During COVID at my community college, they sent out a newsletter saying, hey, we're looking for students who want to do a virtual research experience. And I was really into crypto at that time, which is so embarrassing to say. But I was like, oh, how can I make money? By predicting crypto. And I was like, oh, that's what I can use for life for. Then I was like, wait, I want to be open. I don't want it to be all about making money. I want to hope. And when I came to the US, I talked to him. He said, I'm working on detecting patterns. That's CV. And I was like, that's CV. That's how it's You're both? Absolutely. That's something that a lot of companies try to solve that. You're right. You're right. Teaching, I would say teaching right now. I don't really like in my own freelance projects, I like to do natural language processing, so it's not really okay, so my capstone project finishing my degree here is analyzing social media and detecting if there's toxicity in certain communities where they talk about it's the topics of discussion on platforms like TikTok. What do they make content about? And how do people react to that? Cluster the topics. Maybe they talk about oh, this thing is so difficult. I like this character. Or maybe they just throw this at each other, which happens a lot. And that's what we want to it has an impact on people. You read stuff online, it impacts you. Well, people say fiction stuff and different genres, but they both require I found There are some variations that introduce like what do you need as a prerequisite and you apply that to it. In that sense, I find it simple. To require all of that data to NLP is difficult. Counterfactual. But for acquiring data for CV, like at the city of Gainesville, we were the city of Gainesville to acquire traffic footage